Hi, my name is Bart Polson, and in this tutorial I want to show you how to use the online statistics program StatCrunch to compare the means of two different groups of people on a single quantitative outcome um, using what is called a t-statistic, or a two-sample t-test, or sometimes called an independent samples t-test. Now in this example I'm going to use a data set that I put together on StatCrunch, and if you simply go to, once you log in, go to Explore and then Data, type in seeding choice, it'll bring up a few data sets. This one, seeding choice versus GPA stacked and split columns for front and back rows. It's a data set that originally has a front, middle, and back row, but because I'm comparing two groups, I wanted just the front and the back. I had another one that talked about stacking and splitting, and if you look at that one, it shows you how I deleted a row, I deleted the middle column, and how I created these two by stacking them, and then I actually used an indicator column that to create this one called front row. Created two, one for back row. I had to delete them and then relabel this one, but none of that's really difficult. The point here is I've got data in a few different formats. um, Now what I'm going to do is I'm going to compare the means. These are the GPAs for 10 people who sit in the front row of the class and 10 people who sit in the back row of the class. It's made up data, but you get the idea. There's a couple of ways to do this. Number one is with a two-sample t-test. Now, I want to show, before I do anything, it's important to do your univariate statistics. And let me show you what I did here. I've got a few charts. I'm going to pull them up real fast. This one shows me that, we have an even of 10 people in the back row, 10 people in the front row, whatever, that's fine. This is a box plot to show me that the distribution of scores for people in the front row is much higher than the distribution of people for scores in the back row. Also, they're pretty much symmetrical, and there are no outliers, and that's important. And then this is the same data, just showing the averages. Remember, this is based on percentiles, and so that bar there is the median. If it's a symmetrical distribution, the median and the mean are the same thing, but if they're not symmetrical, then they aren't. Anyhow, the mean here is about 3.5, and the mean here is about 2.8, and this is a confidence interval, 95% confidence interval, which says that, in the true population, maybe the mean for people sitting in the front row is this high or this low, but please note, they're real far apart from each other. That's going to be important. Now I'm going to come back here, and I'm going to do the first thing is what's called a two-sample t-test. I go to Stat, to T-statistics, to two-sample with data. The t-test is actually a pretty flexible test, and this is just a simple version of it. By the way, I don't know why it's called a t-statistic. I know that it was William Gossett, who wrote under the name Student, who developed it, but I don't know where the t part comes from. Okay, we need to tell it where the data are. Now, when you use the t-statistic, you have to have it in this way where the data for one group are in one column, the data for another group are in another column. And so if they came in this form, then you would want to split the columns to get them back to this. Anyhow, group 1 is in the front, group row is in the back. Just leave that right there. And we're going to do a hypothesis test that assumes the groups there's no difference. So we can just leave that how it is and hit calculate. And here we go. It tells us that it's looking at the difference between the two groups and is based on the null hypothesis that there is no difference. We're using something called pooled variances, which is you use that unless you have a reason not to. It tells us that the difference between the two groups means is 0.6367 GPA points. The standard error here is the same as the standard deviation of that difference divided by the square root of the sample size. It's just an indication of variability. And if you take this number right here and divide it by this number right here, then you get this number over here. So this number right here is 4 times larger than this number, which is why this is basically 4. The degrees of freedom here is related to sample size. In this case, it's the sample size minus 2, because we have two different samples going into this. And with the t-statistic and the degrees of freedom, you can get a probability value for this. That's the p-value, the probability value or significance level, which is 0.0009, which says that there is a 0.09% of a chance of getting a difference between group means this big as a false positive. And that is, if we assume there's really no difference and that any difference is just a random fluke, That'll happen less than 0.1% of the time with this particular sample. And instead we reject that null hypothesis and we say, no, there really is a difference. Now I'm going to put this one off to the side for a minute because I want to show you another way to do the data. One way is with what's called a one-way analysis of variance, which is very closely related to the t-test, and you can do it a couple of different ways. Let me show you first off. We can go stat analysis of variance, where the variance is related to the standard deviation. We're going to do one way because I'm using just one classification variable. And you can do it two ways. Number one, you can say I'm using the people in the front and the back, and just hit calculate. And the table looks different. Let me get all of those up here again. But the important thing is actually what's nice is it gives you the means for the two groups. And this is a bunch of intermediate statistics here. The important thing to get at is this F statistic here is 15.9. It's about 16. This is the square of the T statistic, which is about 4. So there's an exact relationship between the two. And look, the p-value that comes from the both of them is exactly the same because they're the same procedure doing the same thing. Again, what they're saying is this group's mean is much higher than this group's mean, and it's not likely to have risen through random sampling error. I'm going to show you two other ways to do this. We had another option with the one-way analysis of variance right here. And that was, instead of having them be in separate columns, you can do this one, and now I can say that the responses, the outcome variable, is the GPA, and the factors, the thing that splits them into groups, is right here in row. And now the analysis of variance is more flexible. You can do it to compare two groups, even though it's not normally used that way. People use the t-test usually. But you can do it to compare 3, 4 more groups if you want. I'm just going to hit OK and calculate. And there we go. And let's get those all together. You see the table's exactly the same. Everything's the same except this part right here. This says data stored in separate columns, responses stored in GPA, factors stored in row. Again, same p-value. One more way to do this is because I created an indicator column that said whether people were in the front row, yes or no, I can also do correlation or regression. So I can come over here to stat, and I can go to summary stats, correlation. And I can do whether they're in the front row, that's a 0, 1 variable, and their GPA. Now I'm going to want to go to the next page and click this two-sided p-value, and I do this. Okay, let's bring them all up again. Now I have a correlation of 0.68, so on, between sitting in the front row and GPA. And look at this. This is the p-value. It's 0.0009. It's exactly the same as here and here and here and here because they're doing the same thing. The nice thing about the correlation is that this number is inherently meaningful. I know what a correlation of 0.68 means. A t of 4 and an f of 16, they don't mean much to me. But this can be used, interpreted in the context of other correlations. Now, I'm going to do one more thing because I'm running out of time. I want to show you, you can also do regression. You're going to come back here to stat, regression, simple linear, where I'm going to have my predictor variable is the row that they are in, and the outcome variable is their GPA. And actually, I can just hit it right here. Actually, I'm going to do one thing here. Plot the fitted line. I almost always do that when I do regression, and hit calculate. All right, let me make this row, this thing bigger. I'm going to bring them all up again. And check this out. It says that the outcome variable is GPA. We're looking at front row. There's the sample size. There's an equation. There's the correlation, 6849. It's the same as what's right there. We've got a whole bunch of statistics here, but look at this, the 0009. Again, it gives the exact same conclusion. The nice thing about this also is it gives me a dot plot that compares the means of the two different groups, and so I can look at the difference. Anyhow, the overall point here is that you can compare the means of two groups in several different ways. A t-test, two ways of doing the one-way analysis of variance, a correlation regression, and they all give you the same conclusion. They all give you exactly the same p-value because they're all related. I hope that helps. Thanks.